Hello everyone. Today we'll be talking about resultant of forces. Now this chapter under Mumbai University has different types of categories of problems. But briefly speaking, there are two types of problems: problems based on concurrent force system and problems based on non-concurrent force system. So, firstly, let us go through the things that we'll be learning in this chapter. Before we move on to the concepts of forces and the things that we'll be learning and the formulas that we'll be learning in the resultant of forces chapter, let us first understand the system of forces. Firstly, we have concurrent force system. Now, what is concurrent force system? Basically, say consider there are many number of forces which are acting on a single point, say point A, and there are many forces which are acting through point A, say F1, F2, F3, F4. So the thing to note in this is that all the forces are passing through one single point A. So when the line of action, say this is called the line of action, it's nothing but an imaginary line through which all the forces are passing. Okay, that is the line or the path which the force is taking. So these are called as line of action. Line of action. So when the lines of actions of all the forces pass through one single point A, we say that all the forces are concurrent. That means all the forces are making a concurrent force system in which this single point of intersection of line of action of all the forces is same. This is called concurrent force system. Okay. Now let's talk about what is a non-concurrent force system. For a non-concurrent force system, we must have a body which is not a point. That is basically the major difference. That is basically the major difference between concurrent force system and non-concurrent force system. That is, in this case, the body on which the forces are acting, that body is not a single point. It is actually a body with dimensions, or dimensions having certain length and certain breadth or height, whatever you can say. So a body having certain dimension will have number of points on itself. That means there will be a point A, there will be a point B, there will be a point C somewhere in the middle, there can be a point anywhere on the edge. So this body has so many different number of points on it, and we can have forces acting on all. I mean the forces having their lines of action passing through them like this. Say F1 is going like this, F2 is going like this, passing through point B. Then say F3 is going like this through point C, and then maybe another inclined force F4 going like this through point D. So what I mean to say that the lines of actions of all the forces in the system, they will not be passing through only one single point like the way we had in concurrent force system. So basically the main difference between the two force system is that here the body, which is the body on which all the forces are acting, are is a single point, and here the body on which the forces are acting will be a body with dimensions, and the forces will be acting at different points on the body. Okay, so to find out the resultant in case of a concurrent force system, it's easy, because in this case the resultant of the entire force system will by default act at point will by default act on the point where all the forces acting. So all these forces can be removed and replaced by a single force R, having making angle theta with the horizontal. So this we can easily find out because the resultant will also act on the point A where all the forces are acting. But in case of non-concurrent force system, the resultant will be passing through the body like this. Now we don't know, of course, the angle, there will be an angle to it, but we will not know at what point on the body is the resultant passing through. Where exactly is it passing on the body? It can be here, it can be above, it can be below, it can be anywhere on the body. Since this body is a rectangular dimension, having a rectangle having dimension and has number of points on it. So the resultant can pass through any point on the body. You can easily find out the value of the resultant, you can easily find out the angle of the resultant. But to find the location that where this resultant will be passing, that is the challenge, or make the non-concurrent force system a little more, more things to be found out compared to concurrent force system. But there's nothing to worry, we'll be learning about how to locate the resultant also. It's not that difficult. I'll explain it as simple as possible. Okay, so this is regarding concurrent force system and non-concurrent force system. Now let's talk about something called principle of transmissibility. Okay, so starting with principle of transmissibility, to understand this principle, let us take a point A on which a force F is acting on the left hand side. It's acting towards point A. Now this is as good as the same point A having the same force F on the right hand side, but this time acting away from A. So as far as the line of action is the same, the angle is same, the value of the force is same, the force, the arrow of the force can be moved along the line of action at any point. It can be moved at any point, and the force which earlier was pushing towards A can become pulling away from A. This is called principle of transmissibility in very simple words. Of course, there's a definition for it in the textbook that you can read and that you can write in the exam if they ask the definition for principle of transmissibility. But to understand in simple words, this is what principle of transmissibility is. Let us move on towards the different types of concepts that we must know before we start solving problems based on concurrent force system and non-concurrent force system. So first let us talk about concurrent force system. In this category of problems, to solve in resultant of forces, we must know two things. Firstly, we must know how to resolve an inclined force into two components, F1 and F2. Okay, so this force R, say making an angle of theta with the horizontal. So how to resolve it into its two components F1 and F2, which are perpendicular to each other. These two are perpendicular to each other, and this is called as a resolution of a force. And we must also know how to combine two perpendicular forces into its resultant. That means the reverse of what we just discussed here. So the suppose if we have two forces, one horizontal, one vertical, F1 and F2, then how do we combine these two forces to get an inclined force R, and what will be its angle? So it's basically both the diagrams look the same. So we are actually doing what we learn here is what we also learn the exact reverse of that in this portion. This is called this is called resolution of force, and this is called combination of forces, or finding resultant of two perpendicular forces. Now, let's talk about the second category of problems in resultant of forces chapter, that is non-concurrent force system. In this category, we other than what we already know over here. So all this thing that we have learned in concurrent force system, that is resolving the force and combining the forces, that is definitely required. And other than that, so all that thing that we have learned here, plus we must also know how to find moment of a force. We must also know what is force couple system, and finally we must also know the Varignon's theorem. So this is sort of an layout out of the resultant of forces chapter, in which we learn the concurrent force system and the non-concurrent force system, and these are the concepts that we must know to solve these categories of problems. Okay, so now we'll be starting with concurrent force systems, and let us first start with learning the concept of resolution of force. Then we'll learn the next concept. Okay, to see how do we resolve an inclined force into its components, a horizontal and a vertical component, we must be given an inclined force making an angle of theta with the horizontal or some angle with the vertical. Either way, we need the value of the inclined force and we need the angle of the inclined force. Now, why do we need an inclined force only? See, an inclined force, we have to resolve it into a horizontal component and its vertical component. If the force is a pure horizontal or a pure vertical force, then there is no need to resolve it into a horizontal or a vertical component. If it is purely horizontal, the entire force is only the horizontal force. If it is purely vertical, the entire force is purely vertical. Only when it is inclined, we have to resolve it into a horizontal and a vertical component. So, let us say we have an inclined force R making an angle of theta with the horizontal. So, this is known to us, this is known to us, this is given. And we have to find out what will be the two components of this force in a horizontal and a vertical direction. So it's very simple. The horizontal component F1 is given as R cos theta, and the vertical component is given as R sin theta, where we know the value of R, we know the value of theta. So we can find out the value of F1, and similarly we can find out the value of F2 also. Okay, now this formula is not compulsory that always the horizontal component will be cos theta and the vertical component will be sin theta. It's not fixed. It depends upon what angle is given to us. Suppose the angle given to us is alpha and not theta, then in that case the horizontal force will be R sin alpha and the vertical force will be R cos alpha. Okay, so basically speaking, the Cos component, whether it will be the horizontal component of the force or the vertical component of the force, it depends upon which reference angle of the resultant or the main force is given to us. If the main force, if the angle given to us of the main force is with the horizontal component will be cos component, and if the angle given to us is with the vertical, then the cos component of the force will be the vertical component of the force. Okay, so this is where we learn how to resolve a given force into a given inclined force into a horizontal and a vertical component. Now let us learn how to combine two perpendicular forces into one single force. Okay, that is called as combination of force or finding the resultant of two perpendicular forces. So say we have two forces available to us. One is a horizontal force F1 and one is a vertical force F2. Okay, these two forces are given to us and their angles are 0 and 90, since it's a horizontal and vertical, so and they are perpendicular to each other. We have to find out the combination of these two, that is the resultant force of these two, what will be the value of it and what will be its angle with the horizontal. Now note that we can find out the angle of the resultant with the horizontal also and with the vertical also. It depends upon which angle we want to find out. Let us learn the formula to find out both the angles. Okay, so we know the value of f1 and f2. In this case, the value of the resultant is given as under root of f1 square plus f2 square. This will give you the value of the resultant force, and the angle theta with the horizontal, that is given as tan inverse of f2 upon f1. Similarly, the angle alpha, that is the angle of the resultant with the vertical reference line, is given as tan inverse of F1 upon F2. We just have to reverse the two forces. Now, how to remember this? Basically, when we are finding out the angle of the resultant with the horizontal, then in that case, the angle theta, while finding out angle theta, the horizontal component of the force must be in the denominator, and when we are finding out the angle of the resultant with the vertical, then the vertical component of the force must be in the denominator. So this way we just learned how to resolve a force into its two perpendicular components, and we also learned how to combine two perpendicular components into one single resultant force. Hello everyone. If you have found my video useful, please like, share and subscribe my video channel. Thank you.